Hey everyone, welcome back, and let's write some more neat code today. So today let's solve the problem, reverse substrings between each pair of parentheses. So this is a really interesting problem. I'm going to go over two solutions actually. So the first one is going to be an n squared solution and an n space. Well, I guess this is the time complexity. This is the space complexity. This one actually does get passed on Leetcode, and this is the one I was actually able to come up with. Now the second one, to be honest, I did not come up with myself. It is a linear time solution, and quite frankly, I think it's going to blow your mind. I've never seen an algorithm like this one, but it's not super complicated, and it makes a lot of sense. When I had my first solution passed, I thought that was the best one, but it turns out there is a better one. I don't know if I would have been able to come up with this one by myself, even if I had tried, just to be honest. But okay, let's get into it. So consider this example. We have an opening parenthesis here, another one here, then a closing one, and then another closing one. What we want to do is take the innermost string in terms of like parentheses and reverse it. So it would look something like this. And then we kind of get rid of the parentheses. So now imagine that our string looks something like this. Not a great drawing, so sorry about that. But then we take that string and then reverse that. So think about it. I is going to go over here. U is going to go over here. And then we're going to take the inner portion and reverse it again a second time. So now it's going to be I love you. And don't take that too personally. Just kidding. So the idea is that some portions of the string are actually going to get reversed multiple times. And also, we want to reverse portions separately. So like first just the inner portion by itself, and then combine it with the other portion and then reverse that entire thing. And you can imagine it could go deeper. We could have deeper levels of nesting. Like maybe there were some parentheses here and we'd reverse this, then reverse this whole thing, and then reverse this whole thing. And before you even start to brainstorm some solutions, let me give you a counter example to possibly a solution you're about to come up with. We see that this kind of part that's in the outermost parentheses is separate. The U is over here, the I is over here. Does it really have to be like that? What about this? Like AB, I guess. And then I put a C over here, just that, or maybe CD. What would happen with this? We'd reverse this, get BA, and now we have BACD. So maybe something like this. And then we reverse that whole thing. We get DCAB. So if you're thinking something like a two-pointer approach, maybe where you reverse this and this, well, forget about it. It's not going to work. Because if there was nothing here, why would we want to swap a character like from the inner portion with this? We wouldn't. I thought that part, what I just said, didn't make a lot of sense, so I got an example for you. This is what I was talking about. Take a look here. The output is this. Now imagine you try to do the two-pointer approach I just mentioned. We have a pointer here and a pointer here. Getting to the first character for each, A is here, F is here. Obviously, this one is more nested than the other one, so what do we do? Swap them? Okay, we'll get an F here and an A over here. But again, I think like now you kind of realize it's not going to work because already like you see that the string does not end with an A here. So that's what kind of made me realize that there might not be a shortcut, that we do kind of have to, in a sense, brute force this. And what do we know about parentheses? Well, if you've solved any of the other kind of common parenthesis problems, you know that a stack is almost always useful. Like that's the only way we can kind of keep track of this portion being separate. Like this is within these two parentheses. And then the amazing thing about a stack is that it allows us to reverse very easily. And I kind of just know that off the top of my head because I've used stacks quite a bit. But I'm going to walk you through why a stack is going to help us here. So we're going to run sort of a simulation. We're going to go character by character and push them onto the top of our stack, including the open parenthesis. So right now our stack might look something like this, open parenthesis. I get a U. And then I'm going to move from here to the next position. So I'm going to get another open parenthesis. I'm really sorry if these look like the C character. That's not what they are. They're parentheses. Okay, maybe that's a little better. Now we're going to go through these characters. Notice how all we're doing is just taking all of these and pushing them onto the stack. That's usually what you do with parenthesis style problems, because it's not until we reach the closing parenthesis that we realize we have a complete portion and we want to take this portion and reverse it. Imagine if we tried to reverse it before we reach the end of it. We try to reverse this. What would we end up with? Something awful. That's not what we want. So wait until you reach the closing parenthesis. Okay, once you get there, like once we get to this, we have this on the stack, and then we reach the closing parenthesis. What are we going to do? Well, we want this portion. How do we get that portion? Keep popping until you get back to the open parenthesis. So what we're going to do, pop first, pop second, pop third, pop fourth. So what we're going to end up with, imagine we take those and store them in some kind of a list. In the order that we pop them, we pop that guy first. So we get E. Pop that second, get V, O, L. So we end up with this, and imagine this is in some kind of a list. Notice how it's reversed. That's the neat thing about a stack. You pop from the stack, and you'll end up with the stack in reverse order. Great. So now what do? Well, do we just take this, add it back to the stack? Pretty much, but we should probably get rid of the open parenthesis there. And watch what happens when we do that. Exactly what we want. So I'm going to pop that as well. And now I'm going to push onto the stack E, V, O, L. And so imagine this is just not even here. We have this portion. And so that's amazing because now we've kind of taken this and concatenated it with the stuff that came before it. And it could have been that nothing came before it. That's perfectly fine, right? It'll work the same either way. So now we're going to do the exact same thing. We have our pointer here. We did what we wanted to do. Our stack is in good shape. Now keep going until you reach the next closing parenthesis. We got I over here. Add that. We got closing over here. Time for the fun part. I'm going to kind of cross this out, but now we're going to pop first, second, third, fourth, fifth, and then we know that the order that they're going to end up in is something like this. I love. And again, we're going to keep going until we reach the open parenthesis. We got U over here. Add that. Finally, the closing parenthesis. We remove that, right? We just get rid of it. So everything has been popped from the stack. We're going to take this and now add all of this to the stack. So by the end of it, our stack will pretty much just look like this. And what do we want to do with all these characters? Pretty much just combine them. So we can turn them into a single string in O of n time. I'll show you how to do that in Python, but that's the general algorithm. Now, it might have looked like it was a linear time algorithm, but keep in mind it's not. It's going to be, in the worst case, n squared. To be a bit more precise, it's going to be big O of n, where n is the length of the input, times m, where m is the number of pairs of parentheses. And this one probably explains to you why the time complexity is like that anyway, because we're going to go through each portion and reverse it, right? It's the simulation that I was talking about. This is reversed, then this entire thing is reversed. If there was another matching pair, that would be reversed as well. So however you want to slice it, this is the worst case. This is a bit more precise. Space complexity is also O of n, obviously because of the stack. Let's code this up. Okay, so now let's start coding it up. I'm going to initialize my empty stack. I'm going to go through each character in the input string S. Two main cases where we care about. If the character is a closing parenthesis, we're going to do some stuff. Otherwise, it's the simple case. Whether it's an open parenthesis or an actual character, we don't really care. Just go ahead and add it to the stack. That's all we care about. Now for the fun part up here. What did I say we were going to do? I said we were going to now keep popping until we reach the open parenthesis and then pop one more time. So the easy way I think to code it up is kind of like this. If the top of the stack is not equal to the open parenthesis just yet, start popping from the stack. With this loop right now, as it is, we will leave the open parenthesis on the stack. So after all of that is done, we want to pop one more time out here to actually get rid of that open parenthesis. Now, the reason I'm putting that out here and not in here is because in here are the actual characters that we want. We are going to save those. I'm going to call it portion. You can call it something else. To this portion, we want all these characters to be added to it in the order that they were popped. So just something like this, portion dot append that character that happened to be popped. And so now we want to take all the characters from this and add them to the stack. We could do that with a loop, but thankfully Python has a neat little shortcut like this, extend that portion. So this will pretty much do what I said earlier. It'll go through all the values in here and push them onto the stack. So it's kind of like append, except instead of accepting a single value, it accepts a list of values. That's pretty much it. What do we do at the end? We don't return the result because it's a list or stack. We want to return a string, so let's join all the substrings in the stack. We can do that like this in Python. Take an empty string, use it as the delimiter, and then join all the strings in the result. So this is the entire solution. Let's run it. I'm very unintelligent today, so we don't have a result variable today. I'm pretty used to that, so we should actually replace this with stack. Let me try again. And now you can see it works, and wow, it's at 98%. So you can see why I thought that this solution was efficient, that this was the most optimal one, but it turns out there is a better one in terms of big O time complexity. Quickly, before I show you that, I just want to say if you're interested in learning more about Python and these sorts of tips and tricks about it and knowing like the time complexities of each operation, I'm actually working on a Python for Coding interviews course. It'll be a fully interactive one, just like this Python for Beginners. Pretty much it'll be like little documentation lessons. It's kind of like an interactive textbook where you can like practice each time you learn something new. If you're a Leetcode Pro member, you'll automatically have access to this when it comes out. Okay, so now we're going to get into the second solution. I really want you to try to be able to come up with it by yourself. So I'm actually going to run like the simulation, and maybe if you're good, you can convert that simulation into the code and probably learn something new from doing that. But if not, that's perfectly fine because quite frankly, it is a very tricky algorithm to come up with. Even though it's simple, it kind of blows your mind because it's like, wow, I would have never thought of that. So let me show you what the solution is. But first, notice something. We saw that this portion got reversed once, and then it got reversed a second time. The outer portion got reversed once. Consider a different example like this one, like maybe A, B, C. I'm just adding random characters. This is one layer deeper. So this layer will get reversed once, and then it'll get reversed twice, and then it'll get reversed a third time. So it'll get reversed however many times it was like nested. The portion out here will get reversed twice. The outermost portion will get reversed once. So in a sense, the outer portion is always reversed. That's not like a huge hint or anything, but it's just an observation, I think, that will help you understand the solution I'm about to show you right now. Because what we're going to do is anytime we see a parenthesis, we're automatically going to go to the other one. So we start at the beginning here, but we know that this open parenthesis has a matching closing one. So I'm going to go over there. So I was here. I'm going to leave a little blue mark just to show you I was here, but now I'm here. And now we can't really go in that direction. We're going to go in the other direction. We're going to alternate. So now I'm going to arrive at I. I'm going to have my result output here, and I'm going to put I there. And that does make sense because we don't really know how many times we're going to end up reversing this portion just yet. We don't know how deep it is just yet, but we know that the last character before the parenthesis here, if there is a character, it's always going to go at the beginning because the outermost portion is only going to be reversed a single time. So it does make sense. Now we're going to go here. It's a closing parenthesis. So anytime we see a closing parenthesis, we automatically go to the matching open parenthesis here and alternate direction. So now we're going to start moving to the right. Now we're going to go character by character, adding them to the result. So this time we're only adding characters to the result. We're ignoring the parentheses. So we add L, we add O, V, E, go through all of these. And then once again, we do arrive at the closing parenthesis over here. So once again, we're going to go to the open matching parenthesis. We were already here though. So are we starting to do repeated work? No, because now we're here again, but the direction is going to be different. Our direction is going to go the other way. Now we're at U. And so now we're going to add that to the result. And this is it. This is the result. Sorry, I had to redraw it, but just to finish up our simulation, we were at the U, we're going in this direction, we're going to be back finally at the beginning at the open parenthesis. But right now, our direction is going in this way. So now, when we go to the closing parenthesis at the end, our direction is going to be in this way. So now, we will increment, and now we reach out of bounds. So that's how you know that we're done. Isn't that such an elegant solution? So I think probably the biggest question you might have at this point is, why does this solution work? Like, forget about even being able to come up with this by yourself, but why exactly does this even work? Well, think of it this way. We start at the outermost layer and we move inwards. Even though we teleport from one end to the other, we still move inwards. We know that the outermost layer should be in reverse order. So of course we're going to start at that character. Okay, and then we're going to keep either getting characters, which is fine, or we're going to reach a parenthesis. Now, going this way, you're not going to expect to see a closing parenthesis. That would be invalid, right? Like if there was a closing parenthesis here, that'd be invalid. The parentheses are guaranteed to be balanced. So if we reach an open parenthesis, we stay inside of that portion. We will teleport to the other side, the open parentheses, so that we can then reverse this portion, but we will stay inside that portion. So it turns out that it's all about the direction that we traverse each portion. And if we start out like this, if we start out going in this direction, that's fine, because we know we're going to get to the end anyway. But for a particular inner portion, we don't know. Should we go through this from left to right, or should we go through this from right to left? Well, that's why we maintain the direction, because it's alternating. Think of this. That string I showed you earlier, which could be arbitrarily deep in terms of nesting, like this. Remember how I said this one gets reversed 3 times, this one gets reversed 2 times, this one gets reversed once. Isn't that the same as saying this one gets reversed 3 modded by 2 times, so only a single time? This one gets reversed 2 times, so it's pretty much like it got reversed 0 times. This one got reversed once, so yeah, that's fine. This sort of tells us the direction. With the approach that I explained earlier, this portion will end up being traversed in reverse order. This portion will end up being traversed in order. And the outermost will always be traversed from right to left. Now, I think this is some of the intuition where you can begin to understand this solution, which is a very good start. If your goal is to be able to come up with a solution like this one on your own, that's a very ambitious goal. And quite frankly, if all you're trying to do is pass an interview, I don't think it's worth pursuing that goal. Okay, I'm editing this in after the fact, but this is some intuition you could use to actually come up with the optimal solution by yourself. Just focus on the output for a second. Notice how we have one portion here, Ji, and that portion is here. Obviously, it's in reverse order. Next, we have a second portion, GH, and that portion here is going the other direction. And then next we have the portion FE. That portion here is obviously going the other way in the output. Lastly, CD, well, not lastly, sorry, it's here. It's going in order. And then here, BA, it's going the other way. So basically, the TLDR is that you can come up with these solutions by thinking of creative examples. And that's something I think I've talked about on this channel before. You can see this is kind of going in reverse order, but each section is not necessarily being traversed like in that direction, right? Like that's kind of the complicated part. The direction is the thing that's changing. So this is, again, just some intuition. In summary, you can kind of tell based on the simulation that this is going to be an O of N algorithm. And in terms of just maintaining the space, like the output, that is also O of N if you count that. And the way we're going to be building it, you kind of have to count it because we're going to have it in an array and then we're going to convert it into a string. Now we're actually going to code it up. And I didn't really explain fully, I think in the drawing explanation, how to code it up. But that's the fun part. We want to be able to teleport, right? So I'm going to first just try to implement the algorithm. I'm going to start my pointer I at the beginning, and I'm going to have my direction initially set to 1. This is basically how much we want to increment I by. Right now it's 1, so obviously we're just going to be incrementing it by 1, moving to the right. But sometimes we're going to set it to -1. That's just an easier way of handling this than, like, we could like hypothetically set this to a Boolean, like true is for right, false is for moving to the left. And then we could have some kind of if statement, like if direction is true, then maybe increment I by 1. Like that would work. It would just take a little bit more code. So I think having the direction be a number is just a concise way to do it. We're going to also maintain our result, which is going to be a list. And then when we return it, we're going to do something like this, .join everything in result. So now for actually running it, we're going to do something like this. while I is still in bounds, there's two cases this time, only two cases. Either this is a parenthesis, the character at I is a parenthesis. It could be open or it could be closed. Or the other case is it's not, it's an actual character. That's the simple case. I'll do it first. Append to the result the character at index I. What about this case? Well, we're at index I. Either we saw an open parenthesis or a closing one. Well, what do we want to do? Well, we want to teleport our pointer. We want to shift this pointer all the way to the other matching parenthesis. We want all matching pairs of parentheses, but we don't really have that information. To get to the other side would be an O of n operation, right? If we're going to iterate over the entire string to get to that matching parenthesis, it's not going to be efficient. So we do some pre-processing, we do some pre-work, some computations. We're going to compute all pairs, all matching pairs. And we can't do this with a left and right pointer technique as you might be tempted to, because consider this example. Something that looks like this. I don't even know if this is a valid example in the context of this problem, but if you had a left pointer here and a right pointer here, you'd say, okay, these are matching pairs. Then you'd go inner, you'd have a left pointer here and a right pointer here. You'd say these are matching pairs, but that's not correct. So that's why we can't do two-pointer approach. We are going to stick to the stack approach. So I'm going to do something like this. For I, C in enumerate the input string. And by the way, if you don't know what enumerate is, this is also something I'm going to teach in the Python for Coding Interviews course. And pretty much all the stuff you see here will be covered. And next, we're going to do something like this. Either the character is an open parenthesis, in which case we're going to append not it to the stack, not the character, but actually the index, because we want all matching pairs. And if we want to, down here, be able to move from one index or one parenthesis to the other, we need the indexes of those parentheses. So up here, we're going to have this stack.append the index I. That's if it's an open parenthesis. We're looking for matching pairs though. So eventually we will find a closing parenthesis, and we know that closing parentheses only close the most recent open parenthesis. And thankfully, we're keeping track of the most recent open parenthesis on the stack. So a closing parenthesis tells us we can now pop from the stack. So stack.pop. And this will give us the index of the open parenthesis. So let's save that here. So right now, my J pointer is at the closing parenthesis. My I pointer, so right now my J pointer is at the open parenthesis that we just popped. My I pointer is at the closing parenthesis. And so what we want to do is just map them. That's why I created this hash map up here to map I to J. So this will be set to J, and the opposite will also be true. So J will be mapped to I. So it's kind of like an edge in a graph, if you think about it, like an undirected edge, like this maps to that, this maps to that. Okay, so we're almost done. This was just a little bit of pre-processing so that we could finish this part in linear time. And now I'm going to show you how you can do that. When you're at a parenthesis, go to the other matching one. So just take our I pointer and reassign it to pair at index I. But that's not enough. Remember, every time we teleport or we switch parentheses, we change the direction as well. So in most languages, you can do something like this, multiply this by -1, multiply the direction by -1. Python is such a beautiful language though, that you can actually do this, where you set it to negative of that. That's why Python is considered pseudocode by many, including me. We're almost done now. You might be able to see which line we're missing. This is stuck in an infinite loop currently. So what should we do? Well, down here, we want to shift the pointer. We're not going to do +1. We're going to do plus the direction. It could be positive or negative, but it will tell us the correct direction to move in. So this is the entire code. Again, if I were you, I wouldn't feel bad if I wasn't able to come up with it. I didn't either, and I'm personally just excited to learn about something so interesting like this anyway, just to keep your brain sharp and just to kind of appreciate the beauty of algorithms. But this is the final code. You can see here it works. It's pretty efficient, but somehow it's actually less efficient than the previous one. Kind of funny. But if you're preparing for coding interview, check out Leetcode.io if you want to. Thanks for watching, and I'll see you soon.